Welcome everyone that is joining from the queue. My name is John Walicki, and welcome to my production studio here in my home office. Just a quick introduction about myself before we get started. I hope you're enjoying your conference. A little background. My name is John Walicki. I'm a Watson Internet of Things developer advocate, and I travel around the US. I inspire developers to build with Watson, and I want them to create IoT experiences that solve interesting problems, which leads me to the topic today, which is taking your IoT sensor data and sending the data to the cloud, do some analytics on it, and finding insights. Because all of our projects are truly about finding the insights in the data. And data by itself is not interesting. The blinky light by itself is not interesting. What becomes interesting is when you can take that sensor and discover some insights from it. And what I'm going to do over the next 45, 50 minutes is share with you the steps that I take to take a sensor. And in this case, we have the Intel Nook. Hopefully you all have one of these. And attached to the Nook, I've got a Arduino 101 with a shield on it. Of course, I've got some sensors. I've got the obligatory blinky light, an LED, a temperature sensor, which we'll be talking about, and of course a rheostat. So we'll do some demos with the edge device and the sensors. So let's get started, and what we're going to do is I'll stop sharing my screen. I'll be back for the Q&A in a little while, but let's jump to some introductory slides, and then I much prefer live demo because live demos are much more interesting for you, a little bit more risky for me, but that makes it fun. And of course, if the live demos crash and burn, we'll flip back to our slides. All right, so let's do screen share. Let's get started. So IoT end-to-end, turning your sensor data into insights using Watson IoT. Feel free to tweet about me at John Walicki. You also can reach me at traditional email. Find me on LinkedIn. So some of the steps, if I were to build an IoT implementation for my company, if I was if I was doing any type of industrial or connected homes, smarter buildings, connected devices, connected products, I would start with a sensor. And the sensors are going to generate temperature, pressure, humidity. They might have RPMs or vibrations. Maybe it's a set of environmental data, water flow, the state of your machine, whatever the device is generating data. There's going to be lots of it. And instead of sending all the data to the cloud, you might want to do some edge processing, typically with an edge gateway. And in the case of the Intel devices, the Intel Nook is a good example of that. There are many other examples of edge devices that can process the data in real time and then filter the data. Because honestly, if the temperature remains 78 degrees and it's 78 degrees for a long period of time, that's not interesting to the cloud. So maybe what you really should only do is send the data that's changing. And of course, you can do that with an edge gateway with some edge processing, some edge analytics towards that. But occasionally you want to send the data to the cloud for additional analysis. And in our case here, an open standard called MQTT allows you to packetize the event data and send it up to the cloud. It's a pub-sub technique, so you can publish. You don't have to maintain an open socket with the cloud. You can publish, send it to a broker, intermediaries, and they can guarantee delivery with quality of service with MQTT. So an open standard created by IBM, but widely used throughout the industry to send messages. Now, in the case of sending data to the IBM public cloud, we have got Bluemix, and Bluemix is going to ingest the data and, as a cloud foundry, send the data over to Watson IoT Platform. Watson IoT Platform is going to route that data to your application where you can do real-time analytics. We'll show you some real-time analytics as it's arriving in the various dashboards. We want to do some processing in the cloud using Node-RED. I'll introduce you to Node-RED and the open source project that Nick O'Leary created 2013. We'll build some dashboards with Node-RED. And then, because the data is arriving, that's only real-time data. We want to actually do some analytics. And so the first step of any type of analytics is to store the data in a time series database. So we'll show you how to do that. And then we'll open up the data science experience, IBM's platform for data analytics, where we can pull our data into a Jupyter notebook, which is a Python. We can apply some Apache Spark libraries and some pixie dust visualization techniques and look for insights. And it's those insights that become really interesting looking for anomalies, especially in industrial machinery. We want to look for anomalies in the production lines. And so these are the steps that I would take to build a production system. So let's get started. So the first thing you do is you need a sensor. And I've got lots of sensors. I looked around my office, found lots of different boxes. You all might have some of these. In the middle, of course, you see the Intel NUC with a variety of Grove sensors connected to it, an Arduino 101. But there are embeds and Raspberry Pis and BeagleBones and TI and Edisons. There's ST Micro and a variety of embed ARM processors, all of which become your sensor data. And then, so in the case of the Intel NUC, I've got, you see the LED and the LCD. I've got a rheostat. I'll show you in a moment live. And you see in the lower corner there, the temperature sensor. We're going to use the temperature sensor to generate data. And we're going to do some anomaly detection for my home office and look for changes in the temperature of my office. All right, so let's exit out of the presentation. We can go on and on with slides, but we're going to jump over to the real dashboard. So here is my browser, and just to show you that it's real, I can turn the rheostat on the Intel NUC, and my browser is, you'll notice I'm on my local network here. It's behind my firewall, and the NUC has a set of firewalls as well. But I've opened up a portal, browser portal from the NUC, and I can look at I can manage my edge device. So this is the edge gateway. Now on the edge gateway, I'm running Node-RED on the edge. So I've launched that. One of the nice things about the Intel NUC is that it's got a set of administration tools, one of which is Node-RED, and you can launch that to do some edge processing. So here I've got, so when you power it up, it has a default flow, which reports the IP address on the LED. But I've built a few other flows. And so Node-RED allows you to grab from the palette a set of nodes and create an application. So in the case of, here's an inject node and a debug node, and we can wire them together, and we can say, hello, we'll inject just a string, And we'll say hello world. If you've not seen Node-RED before, this is obligatory, and I'll say okay, and then deploy that. And then I will inject hello world. And so there's my obligatory hello world. That's not interesting. We'll just delete it. I built an application flow over here where I'm grabbing the Grove temperature from my my Grove sensor, and I'm going to warm it up a little bit. So it was around 79 degrees, and now it's 81, 83. And so I've got my finger on it, warming it up. So I'm converting that to Fahrenheit. I'm constructing a JSON package, and I'm going to send that up to Watson IoT Platform. And I use the Watson IoT nodes that we've added to our palette. So these are a set of functions. You can, of course, go grab a whole variety of different functions. There's over 1,000 different nodes available. Here we see the Grove kit and the mLibra functionality Intel has provided. Now, the sensor data is being sent up to Quick Start, so let's go take a look. Here's the up, of course, now in the cloud, and let's just warm it up. So it got cool again, 79 degrees. So now I'm starting to warm my finger up, touching it on and off, and I'm sending data up to the cloud. All right, so that's Quick Start. Now, before we jump over to the IoT device, let's spend a few minutes talking about the IBM Cloud Platform. And so if you want to sign up for a free trial, it's actually the Lite account is free forever. You get a limited number of services that you can experience and experiment with, but it doesn't expire. There's no credit card, but you can build some applications, some sample applications just by signing up. Of course, I've already signed in, but if you go to, in my case, a new private window, and if you go to bluemix.net, you can go create yourself a free account. No credit card. We just ask for an email to verify that you're not a bot, and then you can get yourself a free account on the IBM public cloud. So in the catalog, you will find over 170 different microservices that you can put together. So, of course, bare metal or virtual servers and containers and block storage, networks and firewalls and databases. You can build with a variety of runtimes. And in the case of runtimes, you might, if your favorite is Node.js, maybe it's Python, maybe it's Java Liberty, maybe it's Go, maybe it's .NET. You can find a whole variety of runtimes available. And in some cases, there are patterns to this. Typically, when you build a web server, you want a database and you want to wire them together. They're API keys. So you would wire together in my case here, the Internet of Things platform starter. The pattern for the IoT platform starter is a database, a web server, and the IoT platform instance itself. So I'm going to take these three components and I'm going to wire them together with API keys. Now, normally you could do that with copy and paste and API keys, and it works. But we've actually built a pattern for you that you can build. And so as part of DevOps, the pipeline, you just create an instance of this boilerplate, and it pre-wires all of it. You can give it a name. In my case, I gave it a JW Intel Gateway. And so you see here, I've created one. It's the JW Intel IoT Gateway instance. I'm using 512 mega memory. I've got one instance running in the US South Dallas data center. And if I really were building internet scale applications, I might deploy it to additional data centers around the world. IBM has over 68 data centers. Typically, we're helping our clients comply with the data privacy rules in a variety of countries, keep the data local, and you can also improve your scalability, fault tolerance, and global scale. But in my case, it's a very simple application. I've got one instance of it running, and so let's jump over to it. So when I jump into the gateway, you see here it's running, how much it's cost me over the last month, and some of the connections I've got wired to it. So of course I have that database where I'm storing my data, and I've got an IoT platform instance, and I've also connected the weather company data. So IBM purchased a weather company, and we've got huge data sets of weather forecasting and modeling. All right, so as part of this, I can go look at the logs and create more instances and deploy with the pipeline and DevOps. Let's just drill into a few of the components here. So I've got a Cloudant CouchDB where I'm storing time series data. And if I want to launch that, now I've been running this for a while to collect some temperature readings. I'm just going to refresh my screen to get you the latest. So here we have Intel Gateway Temperature Readings DevFest. I started a new database for you all, and I've got 4,343 records in that database, temperature. Now, if I wanted to go in that database and look at the data, so here we have a table, and here we have 79, 80 degrees, and a timestamp, because we care about the time sensor data by itself without some metadata. The metadata might be time. It also can be where, and the power of where is very important. So although I don't use a GPS in my little demo today, if you're building an application for IoT and you know where your device is and the environmental sensors, you can start to build blockchains. And as objects move through the real world, record the time, the environmental data, and then where it is, maybe who owned it at that point, becomes really valuable data for insurance, for finance, for trucking, for transportation, for recreation, all sorts of use cases that become interesting when you know the location, the time, and the environmental data. So here we have lots of records in my database. Now, the next instance here is the IoT platform. So let's go launch that. And in the case here, I had created a set of devices. So just to give you an introduction to the IoT platform, we've got boards and devices. You can manage your the number of members. So maybe you've got co-developers or junior developers or administrators and auditors. You can assign different roles in the IoT platform. You can go look at the usage statistics and build some rules. We'll do that. But I just want to show you devices first. So here I've got a whole variety of devices, some of which are new and they're connected. I can go look at my usage for the last, so 57 megabytes in the last month. I've been sending temperature data in a little chart of the temperature data as it arrived over the last couple of days as I prepared the demo. You can build your real-time analytics rules. And so here, in the case of the DevFest, if it goes over a certain threshold, it will start to send me alerts. And so I can do real-time alerts right from the IoT platform. One of the other nice things about my application is the fact that it's running on a URL, and I've got Node-RED in the cloud. Remember, I had Node-RED running local on the Intel NUC. It just needs Node.js, and it's a Node.js application. So here I'm running Node-RED on IBM Bluemix and IBM Cloud, and I can launch into the editor on the cloud side. So here you see that the data is arriving every 5 seconds. I think I've got it set up here. So I'll just warm it up, and there's the data arriving. So we're connected, and you'll notice here as it's arriving, I'm formatting the data. I'm adding a timestamp to it, and I'm going to write that to our database. And remember, I had 4,343 records. And so here I'm just grabbed from my palette a Cloudant node, and that's all I had to do. I just gave it a name and hit deploy, and I'm inserting the temperature readings. You'll also notice that the temperature is within safe limits. So let me just move this debug out of the way here. Once an hour, if I go over a certain threshold, I'll just try to warm it up. I don't know if I'm going to get it over 85. If I warm it up, I can send an alert to my phone. And I'm not sure if I can get it warm enough. I can also extract the data out of the database using a RESTful interface to it. I can go and plot the historical data. So let's go take a look at the chart. So Node-RED has a chart capability. Here I just got a tweet a text from Twilio. I just warmed it up enough. So you'll notice if I scroll down here, it said it was exceeded a message. I'll read you the message. It says, sent from your Twilio trial account, the temperature 86 degrees is critical. And so I triggered my alert from my NUC. And so you can do alerts with that. All right, let's go take a look at our historical data. So the Node-RED platform includes a set of libraries for building dashboards. So I created a little chart. Let's jump over to that and launch the chart. See what this looks like. Oh, I need to inject it so I can start it. Sorry about that. There we go. And it should read the data. Oh, maybe I have to deploy. There we go. And there's the chart of the day. So it was running this morning and I turned it off, and then it was running, and you see it got really hot just a couple of minutes ago when I sent that alert. And so I've now got real-time alerts in a dashboard. And so this is real-time alerts. All right, so now that I've stored the data in a Cloudant database for analysis, I want to introduce you to the data science part of this. So I'm an IoT embedded Linux guy. I'm not a data scientist. But all the insights and the data is what's really interesting. The IoT part of this is really plumbing. The sensors are plumbing. The embedded operating systems are plumbing. And the real value is, what can you extract out of that data? Data by itself is not yet interesting. Let's do some analytics with it. Data science becomes really important. Those of us that thought we would never have to do statistics after Calc 1 are sorely mistaken. So statistics are coming back, and it will be an interesting future as we all do some analysis, machine learning around our data sets. And so what IBM built was Data Science Experience brings all of those components together. Because as I'm just a novice generalist data scientist now, there's a set of open source packages. There's Jupyter Notebooks and Apache Spark and TensorFlow and a set of machine learning algorithms, a lot of different visualization toolkits, Matplot and Pixie Dust. They're all separate. You can install them in your system. Takes quite a while. And what IBM built was a portal. We brought all the open source tools and our own set of algorithms and our own open source, our own open data sets to it. And we gave you a nice capability to manage projects, to do analytics, to use Apache Spark, Scala, Java, and Python in Jupyter Notebooks. And you can collaborate. So here I've got a number of collaborators on a particular project. In my case here, I care about the Intel one. So I'll click in, I'll show you. And I can go learn about data science experience and all the different tools. I can ask questions if I need to. But here I have an Intel project. And if I jump into it as part of my Jupyter Notebooks, I've got I'm installing, so here's my Jupyter Notebook, and I've installed a Pixie Dust visualization library. I'll show you that. And then here's my Cloudant database. I've given my password. Everyone avert their eyes. You can go steal my 4,000 temperature readings. You can now, so here I printed out the temperature and in a table. That's still not insights yet. So I graphed it. I used the Pixie Dust visualization to graph the temperature data. But really what I want to start to do is use Apache Spark. I'll make that a little bit bigger for everyone to read. And what I'm interested in here is the average, the standard deviation, the min, the max from the Intel temperature readings database. And what I found was that the average was 79, that the standard deviation was 5.5 degrees, the max was 107, and the temperature was, when it was really hot, I had my office closed when I was doing my production videos. And then it was really cool in the evenings. So I start to do some analytics on the data set and visualize what I see. So standard deviations become really important because that becomes the anomaly detection. What I want to start to do next is look for anomalies in the data sets, because when it's just a little bit of jitter and it gets warm or it gets cold, it gets warm, it gets cold, that's okay, right? The normal jitter in a temperature plus or minus 1 standard deviation is normal behavior. When I want to start to look for the strange behaviors, the mins, the maxes, the spikes, that's becoming interesting. And so I started to look for standard deviations and what my average z-scores were. And aha, now I start to see some spikes that are outside of the standard deviations. And that's when maybe I need to send an alert. And in one case, I alerted to my phone using Twilio. So you can go back in your historical data set and look for the anomaly detection. You can start to pass this data set to the machine learning algorithms, start to build predictive models. Not only do you know what the temperature was, what the temperature is, what I want to know is what the temperature is going to be based on a set of machine learning algorithms. And in IBM's, we've got a nice package in the catalog. I'll jump over to the catalog just to show you. Jump back and scroll down. Actually, either I'll search or scroll. I may have to search. So we have a machine learning set of algorithms that start to look for anomalies and start to do predicted values. And that's really powerful. When I start to know the forecasts of my data sets, then I can take actions before things bad occur. So take advantage of some of the features of the IBM Cloud. All right, I wanted to show you Pixie Dust because Pixie Dust is a great visualization library. And I use that in my project, an open source project that lets you visualize your data. Now, I just sent it a database, and it figured out how to visualize the charts. And so you can build some really powerful data visualizations using Pixie Dust. I've actually built data visualizations in Node-RED as well with dashboards and charts. I'll just show you some of those. And I'll launch some of the visualizations that we have for this dashboard. And I was looking for some chart examples. So here we've got data visualization in Node-RED using pie charts and bar charts and horizontals. And I'm starting to look for different data. So here was an historical data that I just plotted. And then I can start to do some advanced charts, look at different data sets, and I can pull different data sets in. And so here was 3 different data sets I was plotting. So you can start to do some really powerful analytics looking for, I can smooth this chart out and look for some of the algorithms and use some of the algorithms to analyze my data. All right, so I'm going to end the presentation with where I started, which was this slide here, and remind you where we were. We started with a sensor on my Intel NUC, and it was a temperature and a rheostat and a blinky light. And I sent the data to the NUC for processing in Node-RED. I packetized the interesting data over MQTT, sent it to the IBM Cloud. I did some real-time analytics in Watson IoT Platform, sent the data over to Node-RED, built some dashboards and some real-time alerts, texted my phone when I hit a threshold, stored the data in a time series database, pulled that data into Data Science Experience, opened it up in a Jupyter Notebook, did some analysis in Jupyter Notebooks with Apache Spark, and I used some visualization libraries to build some charts and look for insights. And that's what you would want to do as well. You would want to walk through all the steps. So I get paid to build blinky light demos. Most of you will get paid to build real production systems using IoT data, and you would go through these steps here. All right, so we are going to exit our demos and return to the Q&A. All right, so you can reach me at John Walicki. That's my Twitter handle here. I can just go to Twitter. You can find me on Twitter. So I'm undergoing some research to apply IoT to agriculture, arts and crafts, education, entertainment. That's a lot of different industries. How can you design with Intel? So we all want to build a smarter world. So Intel's a fantastic partner of IBM's. We've built a set of joint solutions where you generate data and then so the Intel device might be the edge and the gateway, and then you could do some edge analytics. But if you really want to do some deeper machine learning, get the data up into Watson IoT Platform, get it into IBM Cloud, and do some analytics with our data science experience. So that combination of an Intel and an IBM become very powerful. So you can apply all the machine learning tools to your data sets. And so the answer to your question is the combination of the two. Use your Intel edge devices with the IBM Cloud platforms to really find some insight, generate data and find insights. Question here about procedures for use of real-time data. So what's interesting, if you're building a autonomous car and you need to make sub-seconds decisions on braking for the crossing guard at the street corner, you don't want that to be done in the cloud. You want to do that local on the in our case the vehicle, but there's other data that you might want to send to the cloud. The engine statistics for analysis that can be done when you're connected with a stronger signal. And so the autonomous car has some sensors that are truly running on the edge and some sensors that collect data, send it up to the cloud for analysis. If you need if your car is not running correctly, your dealers can send you an alert, right? We can go look back at your service history and say, oh, time for a service. And we could tell from the engine data as well. So it's a combination sometimes is what do you need to do on the edge, right, versus what do you need to do in the cloud. And that's where we need data scientists. That's where we need smart IoT developers building the combinations. People ask, well, is doing things on the edge the right answer? Yes. Doing things in the cloud the right answer? Yes. They're all the right answers. It depends on what you need to do with the data, how responsive you need that decision to be before you move on. And so from a procedure or a life cycle perspective, there's certain things in real time that are important. Stop the car before it drives off the road. There are other things that really become interesting when you have a long historical record. And that's important too, right? Because the first anomaly doesn't look like an anomaly until you've collected enough data to look at the trend, to look at the normal behaviors of a device. And you can only do that with a historical record. And real time just shows you a snapshot. It doesn't show you the what's happening now is good, but that doesn't mean I know what happened yesterday or what I want to know is going to happen tomorrow. It's the storing the data that becomes interesting. And then doing the machine learning on the data so that you can make some predictions about what's coming next. Question if Intel gateways support mesh network topologies. So the Intel NUC is a hardwired device. There you can put a Wi-Fi board in it. There's a whole variety of different devices out in the marketplace that can provide mesh networking. I'm not the Intel product line expert. That's a great question. Unfortunately, I don't know the answer. There's a question about workloads, doing work on the edge versus the cloud. And is in the future, can the edge become more powerful enough? So Moore's law has been really helpful at making devices smaller, less expensive, more powerful. And that trend will continue to some extent, and so edge processing is going to be important for sure, but that doesn't mean that only thing that you would do is the edge. I think there's a place for the cloud as well. There's a question about IoT platform and the Watson pricing. So yes, matter of fact, there's a calculator that's very public that you can plug in your data characteristics, how many messages, the size of those messages, and if you're going to do real-time analytics on it, and we give you the price. There's a price as well. And there's a question here about device provisioning. Yes, so I didn't show you, there's a whole fancy section of IoT platform under devices where I can bulk load devices, thousands of devices. You can add devices here. You can manage the devices, and you can do firmware upgrades and pull statistics out about your devices. There's a whole variety of metadata in your schema. I built a flow using Node-RED I just had a spreadsheet of devices, and I imported them all into Node-RED, and I just fired off a device create flow, and I built, I realized you didn't see my screen when I was showing you that. I could show you again. Let me show you. Good. Now you can see my screen again. And so I just jumped over to the Watson IoT platform, and one of the features here was the ability to add a device. You can import an entire list. You can, there's APIs to this as well. So if you wanted to batch load 10,000 devices, there's an API that lets you do that. You get a token, and you can batch load your devices. And that's what I did using a Node-RED. There is an API for device add, device delete, query the status of the devices. So you can use IoT platform to manage devices, but you're also, the plumbing part of it is getting the data off of the device into the cloud. With the free version, can you pull insights into your device? Yes. All right, so if I wanted, so I think the question is, can I send data back down to the device? And in that case, yes. Let me start sharing again. I didn't show you that. I should have. Jump back over to platform. So in my Node-RED flow here, so this is now up in the cloud, and you notice that the data is still arriving. Right, so if I go clear the data, every couple of minutes it still says it's safe, and what the temperature is. That's coming from this tab here. But I can actually not only can I send data up from the device to the cloud, I can send data down. And so I had turned it off. But if I go turn this on, so I can query the weather forecast for, looks like I put in Ridgewood, and I get back the weather forecast, and I construct an MQTT packet. I send it down to Watson IoT platform, and then I receive it on the Nook, and I take the weather forecast, and I scroll it on the LED. And so so I'm sending data back down. Now I could have also hit a threshold alert and blink the light. I have that flow set up as well. I blink the light when it goes over the temperature. And I'm actually controlling that from the cloud. There's a question about electric consumption. So there's a whole variety of specialized devices for that. I have to have one. This is the very simplest one. So this is it's an off-market SmartThings device, and it just monitors my power consumption of a single light outlet. And I can plug in the outlet and get from this. It sends over Zigbee to a hub, and I can get power consumption from this. So the question about power. So there's lots of different electric consumption devices. Someone asked about firmware images. So that's software distribution. What we can do is we collect the firmware version information, And then you can extract that, and now you know the target of devices, the list of devices that are down level, and you can use your software distribution techniques to push the firmware. Now you can use MQTT and other techniques, and you can write edge flows to send the firmware upgrades down to the device. And so it's not built into the platform. We give you the tools to help you do that. So there's a question here about building prototypes and professional projects. So remember, when you build a professional project, you really want to get to scale. You want to be able to manage tens of thousands of devices and really take care of the full life cycle of the device. All right, I think we're out of time. And so what I'm going to do is wrap up here. So thanks, everyone. Encourage everyone to build with Watson, to take advantage of the IoT platform. Enjoy the rest of your conference. Have a great day, guys.